So now look at the list of polyatomic ions. In this polyatomic ion, each compound here will carry charge, so they are radicals. So now we have NH4 here. You will see that the charge on NH4 is plus. How is it plus? Nitrogen is in group 5, so it will carry nitrogen is in group 5, so the charge here will be 3 minus, that is minus 3. Hydrogen is plus 1, but 4 times 1 will be plus 4. Minus 3 plus 4 is equals to plus 1. That means NH4 combined will carry plus. So that is how we have charges on those polyatomic ions. But anytime you hear ammonium, so you should know it is NH4 and the charge on it is plus. So you have to master the list of the polyatomic ions. So, and as you use it often, you will know it. So the charge will be 1, the valency will be 1, but the charge is plus 1. See carbonate. Carbonate is CO3 2 minus. Now the total charge is 2 minus because carbon is plus 4, oxygen is minus 2, so 3 times minus 2 minus 6, so 4 minus 6 minus 2, so their total charge is minus 2. So carbonate will be CO3 2 minus. So but you don't need all those workings, you need it for strange one. So if you hear carbonate, so that is CO3, you should know the charge will be 2 minus, so the valency will be 2. Remember, valency is always positive. So all these polyatomic ion you see here, all the charges you see on top will start for their valency. For example, chromate, you see that the charge you see on top is 2 minus, so that means the valency will be 2. See permanganate, the charge you see there is minus, so that means the valency is 1, so that is, you know, that is minus 1. So see phosphate, the charge you see there is 3 minus, that means the valency will be 3. So valency is always plus, so their charges will serve for the as their valency. Now let's see example. Now let us now name, let's write chemical formula for some compound. Now write down the molecular formula of A sodium triazonitrate 5. So let me do it one by one. So sodium triazonitrate 5. First, we know the symbol for sodium. So we know symbol for sodium is Na. But now what of triazonitrate 5? Now all these ones are now the polyatomic ions. So now triazonitrate 5 is the same thing as nitrate in short, and that is NO3 minus. Please be jotting down this point so I'll write it down. So now NO3 minus is nitrate or triazonitrate 5. So is either you call it nitrate in short or you call it triazonitrate 5. Now look at what we have here. So most polyatomic ions, apart from hydroxide, peroxide and cyanide, so apart from these three, so most of the polyatomic ions end with ATE, that is this ATE here, or ITE if it is short of one hydrogen. Now why elements, single elements end with IDE. I've mentioned this. And all those ones that end with IDE, they are the non-metal. Such like chlorine, it will turn to chloride. IDE. So anytime you see IDE ending, apart from hydroxide, peroxide and cyanide, you should know that it is a non-metal and it is a single element. But anytime you see if it ends with ATE or ITE, know that is one of these polyatomic ions. Now sodium triazonitrate 5. So I said NO3 is nitrate in short, or triazonitrate 5. Take note. Now how is it triazonitrate 5? You know, I told you that, let's say I underline oxygen here based on the previous video. Now what is the valency of nitrogen here? So that will be X. Remember I said you can remove their total charge, so everything will be equal to the total charge. Oxygen normal is 2 minus, so 3 times 2, that will be X minus 6 equals minus 1, because that is their total charge. So S is equals to minus 6 plus 1. So S is equals to minus 1 plus 6. So S is equals to 5. That means this is nitrogen. This nitrogen here is 5, the valency. So this is that is 3 oxygen, triazonitrate 5. So take note. So now let's write a chemical formula for sodium triazonitrate 5. So sodium is Na, nitrate is NO3, or triazonitrate 5. Now the charge on nitrate is minus, so you have to know the polyatomic ions with their charges, and each time you use it you will memorize it. So now nitrate is NO3, the charge is minus, but that charge will serve as valency, but valency is always plus. You won't say minus 1, you rather say plus. Sodium is 1. Now do your crisscross, so this will be NaNO3. So this is sodium triazonitrate 5. So now let's see another one. B, calcium triazocarbonate 4. So now calcium triazocarbonate 4. Calcium is Ca, triazocarbonate 4 is CO3, and the charge on it is 2 minus. So the short form of this triazocarbonate 4 is simply carbonate. Please take note. So triazocarbonate 4 is simply carbonate. So that means this is calcium triazocarbonate 4. So now calcium is 2. The valency is 2 because it belongs to group 2. I've explained that. So the charge on this carbonate is the valency, but remove minus. Do your crisscross. So this will be Ca2, CO3, 2. So this 2 is going to CO3. So and this other one is going to calcium. Now anytime something can go in this subscript, you are free to reduce it. 2 cancel out, so it will remain Ca, CO3. So this is calcium triazocarbonate 5, or calcium carbonate in short. So let's see another one. Let's say C, iron 2. So for you to see Roman numeral, then this is transition metal, and the Roman numeral will stand for its valency. So iron 2 tetra. Remember I said if we have triazo, AO will turn to O. So in spelling it will now be tetrazo. So tetrazo also sulfate 6. So now iron is Fe, and the charge will be 2, a valency, because we have iron 2. We use Roman numeral for transition metal. I've explained that. So tetraoxosulfate 6, that is SO4. Remember all these ones I've mentioned. We've mentioned nitrates, NO3, that is triosonitrate 5 in full. We've mentioned carbonate, that is CO3 2 minus, that is triosocarbonate 4. Now SO4 is 2 minus also, that is tetraoxosulfate 6. So because you have 4 oxygen, that is tetraoxosulfate 6. You know they both carry 2 minus, and sulfur is plus 6, oxygen will be minus 8, plus 6 minus 8, that is 4 times minus 2, that will be minus 2. So their total charge is minus 2. So like that. So now the charge will be 2. Take note, SO4 is sulfate or tetraoxosulfate 6. The short form is just sulfate. Take note. If it is short of one hydrogen, it will be sulfite. That is SO3. So now take note. So do your crisscross here. So that will be Fe2 SO4 2. So the subscripts are the same. So that is Fe SO4. So this is iron 2 tetraoxosulfate 6. So the Roman numeral is because this is transition metal, and we have to find the valency. So that's it. Let's see another one. Let's say I have tetra also sulfate 6 acid. Now anytime you see acid, you should know it is hydrogen. So acid is hydrogen, and the valency is 1 because it's in group 1. So tetraoxosulfate 6 acid. So now what is tetraoxosulfate 6? It's still sulfate, that is SO4. So and the valency is 2 because it's 2 minus. The charge is their valency. So do crisscross. So this is H2 SO4. That is 2 is going to hydrogen, 1 is going to sulfate. So that is H2SO4. This is tetraoxosulfate 6 acid. So let's see another one. We have hydrogen carbonate, that is HCO3 or bicarbonate. So hydrogen carbonate or bicarbonate. So the full will be what? So to call this in full, this is hydrogen triosocarbonate what? So now let's find the valency of carbon here. So hydrogen is plus 1. The one I underline is X. Oxygen is 2 minus, but this is their total charge. Remove it first. So oxygen is 2 minus. So that means I have 1 plus X minus 6 is equals to minus 1, their total charge. So X minus 5 is equals to minus 1. S equals minus 1 plus 5. S equals to 4. So the valency of carbon here is 4. So this is hydrogen triosocarbonate 4. Like that. So that will be the full pronunciation. So now let us say sodium hydrogen triosonitrates 4. So sodium is Na. Hydrogen triisocarbonates, not nitrate, triisocarbonates 4. So sodium is Na. Hydrogen triisocarbonate 4 is HCO3, or hydrogen carbonates, or bicarbonate. So this will now be sodium is 1, hydrogen carbonate is 1, or hydrogen triisocarbonates 4. So if you do crisscross, this is NaHCO3, like that. Let's see another one. So you will see that this part depends on the polyatomic ions. So you have to know this list often. So now let's say we have magnesium phosphate. Magnesium phosphate. Now phosphate is PO4 3 minus, or in full it will be tetra also phosphates what. So bring these 3 out, that's their total charge. Underline phosphates, oxygen is 2 minus, so that will be S minus 8 is equals to minus 3. So S equals to minus 3 plus 5, S minus 3 plus 8, so S is 5. So valency of phosphorus here is 5. So this is tetra also phosphate 5, so that is PO4, or simply phosphate, or tetraoxosulfate 5, phosphate 5. So magnesium is Mg, and the valency is 2 because it's in group 2. Phosphate is PO4 3 minus, so that 3 minus will serve as a valency, but plus 3, valency is always plus. So or tetraoxophosphate 5. Take note, so if you do your crisscross, this will be Mg 3 PO4 2. You will notice now that the subscripts, nothing can go in the subscript, so you leave it like that. So this is magnesium tetraoxophosphate 5, or magnesium phosphates in short. So now let's say we want to write aluminum sulfate. Aluminum sulfate. So aluminum is Al, sulfate is SO4 2 minus, or tetraoxosulfate 6. You will see now, by the time you are doing different naming, you will be able to master them. So study the polyatomic ions. So now aluminum is in group 3, sulfate is 2. So if you do your crisscross, that will be Al2 SO4 3. So like that. So this is how we can write binary compound for polyatomic ions. Now write all this one out, so at least you have the polyatomic ion, you can check and write. So try this on your own. Let me do one that you may not know. Ammonium nitride. Now look at this, it's not nitrate, it's nitride. Look at nitrate, so don't miss the two. If it ends with ATE, then it's polyatomic ion. If it is IDE, then it's single element, that is just nitrogen. So take note of the difference. So now ammonium nitride, nitride. Ammonium is NH4. At least you've seen it again. Nitride will just be N. But if it is nitrate, it will be NO3. So then ammonium is 1. Nitride, nitrogen is 3. Valency. So do your crisscross. So this will be NH3, NH4 3, N. So like that. 1 is going to N. So now, what of iron 2 chloride? So I've told you if you have Roman numeral, it has involved transition metal. Iron 2 chloride is chlorine. So that will be 1. So 2 is going to chlorine. 1 is going to iron. So that is iron 2 chloride. So now, write all this one. Potassium hepto, that is hepta also chromate 6. Now this heptazochromate 6 is the one you see in this periodic, in this your polylist or polyatomic ion as chromate. So chromate is CrO4. Excuse me. So CrO4 so dichromate is Cr2O7. So this Cr2O7 is dichromate, and it is because you have 2 chromates, you say 2 there. But if Cr2O7 rather, but if it is chromate, it's just CrO4. But if it is dichromate, it is, so now heptazochromate 6 is that dichromate, that is Cr2O7, and the charge on it is 2 minus. So this is dichromate or heptazochromate 6. So now this will be potassium K dichromate or heptazochromate 6 Cr2O7. The charge is 2, potassium is 1. So if you do your crisscross, that is K2 Cr2O7. So that is potassium heptazochromate 6. So write this out. So I'll just use the one you have in the polyatomic ions. So write zinc sulfate. So write the full zinc sulfate or zinc tetra also sulfate 6. So write the chemical formula. So write sodium, write calcium nitrate or calcium triazonitrate 5. Write copper, so based on previous video, copper 1 oxide. So write potassium, we've done that one. So write ammonium phosphate or ammonium tetra also phosphate 5. So like that. So now in the next video we will see more example.